Hello and welcome to this video, Ansible Playbooks, Creating and Executing. We've covered the architecture and design used in Ansible. We're going to use this knowledge and we're going to get hands-on and put this into practice with a scenario involving an interesting project. We're going to install the Nginx server on both CentOS and Ubuntu. We'll do this at first as you would for each respective version of Linux. We'll then look at this a bit further and see how some of the modules in Ansible cater for different OS variations. We'll look into some of the differences for Nginx as a service on CentOS and Ubuntu and how we can cater our playbooks for variances so that we have a consistent outcome. We'll make use of Ginger 2 to customize our website. There's an Ansible gem known as Ansible Managed, which is great when Ansible is being used for configuration management. It essentially allows us to leave a marker with an indication that a file or resource is managed by Ansible and shouldn't be edited. We'll look at how we can leverage this. Lastly, we're going to have a bit of fun and install a secret Easter egg into our deployed application. This lecture is being given as a challenge, as there's a lot of information we've already covered and the challenge really puts a lot of this into effect. Again, as always, you have a choice whether you start from the solution or the template directory, but in this case, I strongly suggest taking the challenge. It will put into play a lot of the context that we've already done in the previous sections. Our challenge: firstly, update the playbook so that we're targeting the Linux group of hosts. In the solution directory, revision 0 and the template directory are the same files, and these are a starting template base to use for this exercise. Next, both CentOS and other similar variations like RHEL or Amazon Linux use yum/dnf for their package management. We're going to use the Ansible yum or dnf module to install EPEL, the extra packages for the Linux repository. Which one you use, yum or dnf, is your choice. This is required on CentOS-based systems to install Nginx. I want you to give this task a name of install EPEL. If you look through the options for the yum or dnf module on the Ansible documentation or using Ansible doc, you'll see the options for update_cache and state. As our Linux group comprises of both CentOS and Ubuntu hosts, we will need to use an Ansible fact to decide when, and that was a clue, when to carry out the task. So if you're going to attempt this, pause the video and make your changes to the template file. If you're along for the ride, figure out how you would do this and step into revision 1. Pause the video here. Okay, and if you take a look at our playbook, you can see there, under our host section, we've got hosts of Linux. In the task section, you can see we're installing EPEL. I'm using the yum module to do this. The name of the package is EPEL-release. Update cache is yes, and the state is latest. Lastly, we have the when criteria, and we're being implicit for the Ansible_distribution to equal CentOS. Okay, let's give this a try. Okay, great. So you can see there it skipped the Ubuntu host because of our when condition, but this has been successful for our free CentOS hosts. Okay, so the next tasks. We're going to install the Nginx web server on both CentOS and Ubuntu. Create a task called install Nginx CentOS. Using either the yum or dnf module to install the package Nginx. Again, use the same update_cache and state options as we used before. Also, you can reuse the fact check to make sure that we're targeting CentOS. For Ubuntu, it's the same, but instead of using yum, we're going to use apt, the advanced packaging tool, to target the Ubuntu-based hosts. Both yum/dnf and apt share common options, so they should look very similar. Pause the video and give this a try, or move into revision 2. Okay, so you can see there now that we have our additional tasks. One to install Nginx on CentOS, and one to install Nginx on Ubuntu. Hopefully now you've got something similar or something that provides the same outcome. If we run this, we can ignore that warning there. We've now got Nginx installed on CentOS and Ubuntu. We've respectively installed Nginx on both CentOS and Ubuntu, and we've seen the direct options for yum/dnf and apt for the variations of Linux. You'll note the commonality, and we can actually simplify this even further and remove the respective when clause through the use of the package module. If we use the package module, we can just say install Nginx, and it will respectively use either yum/dnf or apt in the background as required. Pause the video and give this a try, or move into revision 3. Okay, so you can see here that this is a lot simpler. We remove those two tasks and replace them with a simple task of install Nginx, which should work for both CentOS and Ubuntu. Let's give this a try. Great, that's worked, and we have green output there because this was successfully done in the previous attempts. We know that we're now able to actually do this with a single task. Let's actually take a look and start interacting with Nginx. We'll need to ensure that the Nginx service is running for us to do this. Create a task called Restart Nginx. This time, use the service module to target Nginx and give a state of restarted. There are other states you could use here that would work equally, but here it's nice to show that we can, if desired, implicitly restart services, which could be handy if you'd performed some kind of configuration change with Nginx. Pause the video and give this a try, or move into revision 4. Okay, so there we have our task to restart Nginx. Let's give this a try. In the output, we can see that Nginx is restarted on all the Ubuntu and CentOS hosts. If you recall, our lab comes with a reverse proxy, which makes it nice and convenient for us to access the web server from each one. So now, if we go back to the portal, and then we choose reverse proxy, and if we click one of the Ubuntu hosts, you can actually see there that we've got the base Nginx web server message. This is the default one that actually comes with Nginx. And then if we go back, and here we choose a CentOS one instead, you can see that we've got the customized version of the default Nginx page. And even though we're running in CentOS, this is the page that is used on RHEL, Red Hat Enterprise Linux. So we've made some nice progress already. We did, however, as we were doing this, assume that all of this was working. And when working with automation, it's not always good to make an assumption. For example, Nginx could have restarted and then may have failed to initialize. What we're going to do in this task is create a handler called check HTTP service. We're going to use the URI module, and we're going to use a fact we covered previously to create a URL with the IP address for each possible host. If a HTTP request is successful, we would get back a status code of 200. Remember that for a handler to work, it needs to be notified. So, update the Nginx task to notify the check HTTP service that you're going to create here. This, by the way, was the reason that we opted for the restart Nginx on this exercise, as this is guaranteed to create a change every time it runs, therefore invoking the handler. Pause and give this a try, or move into revision 5. Okay, so you can see there that the restart Nginx task has been updated and it now has a notify for the check HTTP service. And within the handlers section, we now have a task which is essentially the check HTTP service. This is using the URI module. The URL it's checking is going to be derived using an Ansible fact. So there we're taking the Ansible default IPv4 IP address for each of our respective hosts. We're just checking that URL, and the status code we're expecting back is 200. Okay, great. So you can see there the restart Nginx triggered a change, and because that triggered a change, our handler has run, and we've got green success for all of them. Our web servers are successfully returning the page, which is resulting in a 200, which is a successful error code. Okay, one thing I want to bring your attention to. We just go back from here to the reverse proxy, and we look at the rel CentOS equivalents. You can see there that CentOS/rel makes use of the path /user/share/nginx/html, whereas Nginx on Ubuntu is using the default Nginx base of /var www/html. When we deploy our website, we're going to need to take this into consideration. Therefore, we're going to make use of group vars to specify a respective value for the website location on both CentOS and Ubuntu. Then we're going to put our Ginger2 template in knowledge into play, and we're going to use the template module to overwrite the existing index.html with that of our template. For the destination, we'll be referencing the variable we set in task 9, and the permissions for this will be 0644. Again, pause and try this out, or move into revision 6. Okay, so we have the addition there where we are actually templating the index.html.j2 file. And we are using the Nginx group location group var. And the mode is set to 0644. Okay, let's give this a run. Okay, great. So we've templated our custom template to override the default index.html on both systems. And if we take a look at Ubuntu or CentOS 1, or any of the other Ubuntu or CentOS hosts, we should now have our website page. Okay, there's me, your author, and that's me in front of my shed there in my garden. And we've got an overview of the page and the various sections that make up this course. Next, we're going to look at Ansible Managed. This essentially allows us to make reference to a variable in our templating activities that can be useful for designating how an action was derived. Let's see this in action. Pause the video and carry out tasks 11 or 12, or go to revision 7. Okay, so first, if we have a look at the Ansible config, you can see that we've got the addition of the Ansible_managed entry there, managed by Ansible with the file name, the host, and the UID. And if we take a look at the actual template file that we've changed to, you can see that we've actually injected this into the template. So we will have dive into Ansible, and then right underneath that, we should have a section relating to what we just saw in the ansible.config file. Let's run this and give this a try. And if we actually check one of our hosts via the reverse proxy, you can see there that we've got the additional section managed by Ansible. We've got the full path to the actual file that we're using as the template. It referenced that this was carried out by Ubuntu-C, and the user ID who actioned this was Ansible. Okay, great. So it's quite nice for me being on the website, but let's customize this so it's a bit more appropriate to distinguish between CentOS and Ubuntu. There's a variables file that is provided in the template that we're not using yet that has data entries corresponding to the CentOS and Ubuntu logos. Update the playbook so that we're using this variables file. We're then going to update our reference to the template to one that makes use of these logos. Again, pause the video and give this a try, or go to revision 8. Okay, this time I'm going to bring up this file with more rather than cat because the changes would have been made to the top of the file. And you can actually see there in the vars section, so we've got a reference to vars files, and in this we're referencing vars/logos.yaml. Then at the bottom we're referencing the new template file, which is index.html-logos.j2. And if we run this, and if we refresh this page now, there we go, my face has been changed to the CentOS logo. And if you have a look at one of the Ubuntu hosts, you then see the Ubuntu logo. Okay, so we've got this far, and now we get to the fun bit. If you're not familiar with the Easter egg phrase and how it relates to technology, it's where you have something that's usually hidden that is most often fun or interesting. We're going to add an Easter egg to our deployed site so that when someone clicks the image, they'll go to our secret game known as Playbook Stacker. Okay, so the first task is to install unzip so that we can unzip our code into the website root. For this, we're going to use the Ansible unarchive module. create a task called Unarchive Playbook Stacker. We're going to use the unarchive module with the parameters of source being the location of our playbook_stacker.zip, a destination of our Nginx_root respectively for Ubuntu or CentOS, and a mode this time of 0755. Next, we update our template to use the code with the Easter egg, which changes the image to a hyperlink. Pause the video and give this a try, or go into revision 9. Okay, so there you can see we're installing Unzip using the package module. We're then unarchiving the Playbook Stacker game using the unarchive module, which is actually reliant on Unzip above. We've got the source, the destination, and the mode set. Let's give this a try. Okay, perfect. So that's worked as expected. If we go back to our page and we refresh, what should have actually happened there is the logo is changed at the top. That becomes a hyperlink, and I'm just going to give this a try. And if it all works as expected, our game should start playing. Okay, I'm going to give this a quick try. And naturally, I've had a lot of practice on this. And we should see some Ansible balloons. There we go. There's 2 different balloons. And we should get some aeroplanes. There's both an Ansible and a DevOps aeroplane. There's the Ansible one. And there's the DevOps one. Oops, okay. And there's the Ansible rocket. Oopsie. Okay, that's my high score today, 650. Give that a try and see how you get on. I hope you enjoyed that last bit of fun with this section. In the next one, we're going to be moving on to Ansible Playbooks Advanced Topics.